So here's another problem from 9.3. It's going to be a little bit more complicated than the last one, but the ideas that we're using are really very, very similar. So we want to find the exact values of sine 2x, cosine 2x, tan 2x if tan x is 4 and x is in quadrant 3. So this sine 2x, cosine 2x, tan 2x makes me think of these double angle identities, and somehow I'm going to use this given information about tangent to figure out the values of sine 2x, cosine 2x, tan 2x. And what I want you to think about is, like, we're always going to want to get sine and cosine first. So we first need sine x and cosine x. Since we know something about tan x, if we can first find out information about sine x and cosine x from tan x, then we can use the double angle identities to start figuring out these values we really want. We're given the fact that tan x is 4 and x is in quadrant 3. Now that we're getting used to that quadrant information, again, that's probably just there to help us pick plus or minus signs along the way. And in quadrant 3, it's true tangent is always positive in quadrant 3, so that's a good sign. Our tangent is positive. And so I'm going to, again, start out two different ways and let you choose. You don't have to do both of them, but I want to work through the steps of both. And so our first method is using that Pythagorean identity, the sine squared plus cosine squared is one identity. But now, wait a minute, we got tan x is 4. That's not sine or cosine. So what I'm going to do is I'm going to rewrite this as sine x over cosine x equals 4. And I am going to use sine squared x plus cosine squared x equals 1. I'm going to think of this as a system of two equations and two variables. I can multiply both sides of this equation by cosine to get sine x equals 4 cosine x. And it's this 4 cosine x now that I can put in place of sine x in the other equation, right? And what that allows me to do is rewrite the sine squared as 4 cosine x squared plus, I'm just going to recopy, cosine x squared equals 1. I think we did this type of thing at least once before. I get 16 cosine x squared plus, I'm going to think of this as 1 cosine x squared equals 1. And then I'm going to combine like terms on the right-hand side. 16 plus 1 is 17. I know there's something else magical about this, isn't it? 17 cosine x squared is 1. And now divide by 17, cosine x squared is 1, 17. And now I take square roots. So cosine x is plus or minus the square root of 1 17th. And I got to make a choice. Here let's see, my quadrant is 3, right? We were given that information. Quadrant 3, cosine is negative. I can take square root of 1 is 1, but I'm stuck with that square root of 17 in the denominator. And now I still need to, we also want sine x. We got our value for cosine x. But as I said up at the top, we first need to find sine x and cosine x. So I'm going to try to save a little space here. And I'm going to use the fact that sine x is 4 cosine x. And so sine x is 4 times negative 1 over the square root of 17, which is negative 4 over the square root of 17. And there's my value of sine x. And so we went from just knowing tangent and the quadrant, using the Pythagorean identity, actually a system of two equations, where we did a substitution to get just cosine, and then we were able to figure out values of sine and cosine from that. That's sort of an algebraic way of doing things. Now, before we finish the problem, we're really almost done, but I'm going to pause and start all over again with our method 2 process, because I want to be able to compare these right near each other. So I'm going to apply our method 2, which I think I called using a reference triangle and SOHCAHTOA. And it accomplishes the same thing. It's just going to get us these values of sine x and cosine x, but in a slightly different way here because we're working from tangent. So we're going to, again, take our tan x is 4, but we're going to use the reference angle for x. And I just write REF angle, because we're not calculating with it so much. I don't even want to give it a variable name. I just want to be able to draw it in my triangle. Tangent of the reference angle is also going to be 4. And we want to think of that as opposite over adjacent in our SOHCAHTOA. So I can write 4 over 1. And so let's see, opposite to the reference angle, adjacent to the reference angle is like so. Now some people say, why don't you just write x in this corner? I mean, tangent of x is positive, but you know, x is actually in quadrant 3, and the sine and cosine of x are both negative, so SOHCAHTOA doesn't give us negative values. That comes from other quadrants. So I call this the reference angle. That's an acute angle between 0 and 90 degrees. All the values are positive. I work in a positive world, and then I refer back to my quadrant to change signs when necessary. Now we need a value for the hypotenuse here, so maybe I'll just call that c. I think I can bring a c in here. And the Pythagorean theorem here tells us 1 squared plus 4 squared is c squared. And so 1 plus 16 is c squared, 17 is c squared, so square root of 17 is c. I mean, that's the same square root of 17 that we saw in method 1. Again, there's some efficiency to getting it here. We know c is square root of 17. It's got to be positive because it's a side of a triangle. Length is positive. So now we want sine x, and we want cosine x. And we're going to get sine x and cosine x using SOHCAHTOA. I'm sorry, we want sine x and cosine x, but maybe I should say we have, I don't like the way I wrote that. We don't have sine x and cosine x yet. We have sine of the reference angle and cosine of the reference angle. And that's where we can use SOHCAHTOA. Opposite over hypotenuse for sine, adjacent over the hypotenuse for cosine. And I go back to my right triangle for the reference angle. So reference angle opposite is 4 over square root of 17. Adjacent over the hypotenuse is 1 over the square root of 17. So this is it's sort of cool to have a visual of where these values are coming from. There's definitely some nice things about this method. And again, notice how similar we are to what we found out up above algebraically. Now I'm ready to write down what sine x is and cosine x. And to write these values down, I got to remember that x is in quadrant 3. So I know that sine and cosine are both negative there, so it's negative 4 over the square root of 17 and negative 1 over the square root of 17. So it's the same thing I figured out in method 1, a little bit less algebra, more geometry. I say it's a geometric approach as opposed to an algebraic approach. And now we got to finish our problem, because we did exactly the same, accomplished the same thing in both method 1 and method 2, but now we got to get down to actually figuring out what sine of 2x is, cosine of 2x, and tangent of 2x. So now, and things kind of flow from here. Sine of 2x, I'm going to use the double angle identity for sine. Sine of 2 times an angle is 2 times sine of the angle cosine of the angle. So I'm going to take 2 times my value of sine and times my value of cosine, which I can copy down from either method 1 or method 2. I'm going to use the values that we found. Negative 4 over the square root of 17 times negative 1 over the square root of 17. And notice that negative times negative, 2 is like 2 over 1. I get a positive 8 over square root of 17 times square root of 17 is 17. I get a positive 8 over 17 for sine of 2x. Oh, so, well, 2x, that angle is definitely not in quadrant 3. Sine is positive, so we got to be ending up in quadrant 1 or 2, I guess. Okay. Now cosine 2x. I can use any one of those 3 forms, the identity for cosine. I'm going to use cosine squared x minus sine squared x. In fact, I could also, well, try figuring it out from 8/17. But the funny thing is, we don't really, I don't yet know exactly what quadrant I'm in with this 2x, because it could be 1 or 2, and that doesn't tell me whether cosine is positive or negative. So let's plug in here. So the cosine value was that negative 1 over the square root of 17 minus negative 4 over the square root of 17 squared. So I got a lot of minus signs to keep track of. When I square, I get 1/17 positive minus, I still have minus in between, 16 17ths, because I got to square 4, becomes 16. But the square root just gives me 17 back. So it looks like I get 1 minus 16, negative 15 17ths. Well, I get a negative value for cosine. Sine is positive, cosine is negative. Well, I guess I know which quadrant I'm in now, right? Got to be in quadrant 2, but I didn't know that till just now. There's my value of cosine 2x. And now we're almost done with the problem, but we also want a tan of 2x. And don't use a special identity for that. We're just going to rely on taking the sine and dividing by the cosine. So that's positive 8/17 divided by negative 15/17. And I'm just going to write this out as a reminder for you folks who need to be reminded about fraction division. It's 8/17 times the reciprocal of the second. 17s will cancel. we got positive times negative is negative 8/15. The tangent value is negative 8/15. So there's my value for sine 2x, cosine 2x, and tan 2x for this problem, and that was a big problem. But remember, we spent a lot of time talking about two methods. You only have to do one of those two methods. You don't have to do both. And we'll stop there for this segment.